All right, good morning, guys. So I know that we said last week that on Monday you were going to have a homework, but instead we're going to switch it up. That way, from here on out, this is what it's going to be. Mondays and Wednesdays, you're going to have videos, and then Tuesdays and Thursdays will be the homework pages, and then every Friday will be your test. Your test is not going to be up until Friday at 7. Okay, so if you have any questions about that, feel free to either email me or send me a message on Remind and I'll explain it. But for today, this is what you're going to be doing. Okay, this again is due at midnight tonight. So our next type of exponential word problem topic is compound interest. So this involves like all the banking. So if you put this amount of money into a bank account and it gets this much interest, how much money are you getting back? And this is good to know for you guys. That way, once you start, getting into your own banking and opening up savings accounts and whatever, you can see what bank offers the best interest rate for you and what works for you. Okay, so compound interest is when a fixed interest rate is applied to a principal amount. A principal amount is like the starting amount. So for example, if I open up a savings account and I put $100 in, $100 is the principal amount. So that interest rate is applied to the principal amount and any accumulated interest. Okay? It's when a fixed interest rate is applied to a principal amount and any accumulated interest. So let's say in 2020, I open a savings account with $100. That ends up getting $5 in interest for the following year, right? So now I have $105. The following year, the interest rate's not going to change, but the following year, I'm going to get more money because I'm taking a percentage of $105 instead of $100. Okay, it's the principal amount plus any interest that has been gained. All right, so this is your formula. A equals P times 1 plus R divided by N raised to the NT power. Okay, so it's a little bit more going into it. This is 1 plus. So this is an example of exponential growth, right? We want the interest rate, the interest is going to increase our bank account. So it's exponential growth instead of decay. So your variables, A, just like before, A is your end amount. A is your end amount. P is your start amount or your principal amount. R, again, is the rate as a decimal, so you have to move the decimal over twice again. R is the rate as a decimal. Now, N is a little weird. N's the new one that's involved in this. N is the number of times that the interest is being compounded per year. It's how many times does that account gain interest? How many times does that account gain interest? That's for N, they're kind of together. And T is obviously time. Now in this case, time is going to be talking about years, but T is time. Okay? So everything's the same. The only thing that's new is the N value. Okay, so let's just talk about the N value. If it says that it's being compounded annually, think if something happens annually, how many times a year does that happen? Something happens annually, it happens once a year. So if it says compounded annually, then you're going to plug 1 in for N. If it says it's being compounded semi-annually, if you think of a semi-annual sale, those happen twice a year. It happens every half year, so twice a year. Quarterly, there are 4 quarters in the school year, 4 quarters in a football game, 4 quarters in $1. If it says compounded quarterly, it's 4 times. These are the 3 in real life that you're going to see the most: annually, semi-annually, and quarterly. Monthly, if something happens monthly, there are 12 months in the year, it happens 12 times. Weekly would be 52 weeks in the year, and daily would be 365. Okay, if you see any bank that offers 365 a daily interest rate, then that's insane. Okay, don't worry about leap year. That's like the most common question that I get. Don't do 366 depending on the year. It's always 365. Okay, so let's look at these examples. Number 1. Rebecca deposits $800 into an account that pays 3.25% interest compounded quarterly. Algebraically determine how much she will have in the account after 10 years. So again, I'm going to write down the formula. Right, we have A equals P 1 plus R over N raised to the NT. That way I know this is the formula that I'm working with, and then we're going to figure out what we're solving for. This is algebraically determine how much she will have. That's the future amount or the end amount. So we're trying to find that number. So we are going to be solving for A. We're solving for A, so we have to plug something in for P, for R, for N, and for T. So P is how much money she invested. So she deposits $800. So P is $800. R is the rate. So she's paying the account is paying 3.25%. If you move that decimal 2 times to the left, that gives you 0.0325. And it says that it's 3.25% interest compounded quarterly. If it's being compounded quarterly, that means 4 times a year, she is going to see an increase in her account from the interest. And we want to know how much money she's going to have in the account after 10 years. So T is 10. Okay, so I plug all of this in. So this is now A equals 800 times 1 plus 0.0325 divided by 4 raised to the, again, 4 times 10. N and T up here, this 4 and 10, they're both in the exponent. So it's raised to parentheses 4 times 10. So now again, you have to think, where is my variable? The variable is on one side of the equal sign, just waiting for you to plug the other side into the calculator. So we are rounding to the nearest dollar. So that means no decimals. No decimals, right? No cents. So when we plug this into the calculator, and if we round correctly, we would get $1,106. Okay, so she went from 800 to 1106 in 10 years. Okay, and that's it. That's it for number 1. Number 2, Charlie's parents give him $2,500 to invest as a graduation present. He decides to invest this money into a savings account that pays 3.8% interest compounded semi-annually. Algebra can determine how many years, round to the nearest whole year, it will take for the account to accumulate $4,000. So again, we write down the formula. A equals P 1 plus R divided by N raised to the NT power. Here, algebra can determine how many years. So we are solving for T here. So we plug something in for A, for P, R, and N. Okay? Again, the reason why I like to do this on the left side is that way it gets rid of the word problem, so you don't have to worry about all the wordiness that's above it. Once you have everything, you just plug it right in. So Charlie is starting off with $2,500. He decides to invest this money into a savings account, pays 3.8% interest. So your rate, move the decimal twice, is 0.038. And that interest is being compounded semi-annually. Again, if you look at that list up here that I gave you, semi-annually means that it's happening 2 times a year. How many years before it turns into our final amount of $4,000? So I plug this all into the formula. So we have 4,000 equals 2,500, 1 plus R over N is 2, raised to the 2 is N, times T, which is what we're solving for. okay? If you want to clean up what's inside the parentheses, a lot of people do like to do that. So before I even do anything, if I wanted to actually type this into the calculator, that is the same thing as 1.019. If you want to, you don't have to, okay? But just so it might look a little bit cleaner rather than having that fraction in there. So first step, you divide both sides by 2,500. And the reason why is because, again, look where your variable is. Your variable is in the exponent, so you're going to have to use logarithms for this. Divide both sides by 2,500. You get 1.6 on the left side equals 1.019 raised to the 2t. To bring the 2t down, you have log 1.6 equals 2t log 1.019. Now you're going to divide by the log 1.019. Now before, when you divided the logs away, you ended up with your answer. In this case, you're going to end up with nt. In our case, n is 2, so we're going to have to do an extra step after dividing by 2. So log of 1.6 divided by log of 1.019. Again, that's not your final answer, so you're going to write 5 decimals, 24.97129. And then lastly, divide by 2. Divide by 2, and you get t is equal to, and now you can round, you get 12.48, blah, blah, blah. We are rounding to the nearest whole. So the 4 tells me to keep this as 12. And our answer is 12 years. So it'll take 12 years if you invest that money for $2,500 to turn into $4,000. Okay? Again, the video on Edpuzzle, well, this video on Edpuzzle and the notes are due tonight at midnight. Tomorrow you're going to see the homework assignment for it. And your test is on Friday. It won't be posted until Friday at 7 a.m. and then it's due at midnight. As always, if you have any questions, let me know. Have a good day.